Kindly remember to subscribe, share, comment, and also like on how these lessons are being helpful to you. So, today we take something new, that is on algebra, and we just dive in to quadratic equations. So, what is a quadratic equation? When you have an equation written in this form, a x squared plus bx plus c equals to 0, where x is the unknown term, and a, b, c are constants, then this equation is called a quadratic. Then this is called a quadratic equation. So quadratic equations are given in this form: a x squared plus bx plus c, where now the highest degree in terms of the power is 2. So when you have the unknown having a power of 2, then that one is a quadratic equation. Now the solutions to x are called the roots, or another name is also called the zeros. So the solutions to x are called zeros, and 3 quadratic equations are you can get a quadratic equation by multiplying 2 linear equations, and those 2 linear equations are what we call factors. So a quadratic equation is achieved, or is achieved by multiplying 2 linear expressions. So when you multiply 2 linear expressions, you get a quadratic equation, and now the linear expressions are called factors. So these are called factors. So these 2 factors, when you multiply 2 or more expressions to get a certain, when you multiply 2 or more expressions, you get something we call, for you to get a certain solution. So in our case here, they are linear expressions, then we call them the factors. So for example, you can multiply x plus 1 and x minus 2. So when you multiply these 2 and you equate them to 0, and you get these 2 to be equal to 0, whatever you get from these 2 factors are what we call the quadratic equation. So therefore, I think we have the basics. So we have quadratic equations appearing in this form, where now the solutions to it are called the roots or the zeros, and the quadratic equation is achieved by multiplying 2 linear equations, 2 linear factors, so our expressions. So when you multiply the 2 of them and equate them to 0, then we say that is a quadratic equation. Now we're going to check different methods of solving a quadratic equation, and first we shall start by factorization. So let's check how to solve a quadratic equation by factorization. So therefore, when you have, we check factorization. So when you solve quadratic equation by factorization, it just means you take like terms together, or take factors that are appearing, they are the same in a certain equation, and grouping them together for you to find a certain solution. So as we are solving them, in short, what we are saying is we're going to be getting the roots or the zeros. So that is what we're going to achieve by solving a quadratic equation. We're going to get the roots or the zeros. That is, we're going to get the values of x which satisfy this particular equation. So when you say which value of x will you put here, and which value of x will you put here and here, so that this equation gives us a 0. So what values of x are we going to put here for you to get a 0? So those are what we call the roots. Now, let's take an example 1. When a is equals to 1. So we're going to check the first example where you have your a being equal to 1. So let's take the first example. So example 1. So being given an equation x squared plus 5x plus 6 equals to 0, and you're told to solve that using factorization. Now, using factorization, we find two things. We find two numbers which, when you multiply, so we say we find two numbers whose product gives you the value AC. So the product gives you AC, while the sum gives you the term at B. So we're going to find two numbers, so two integers, which when you multiply gives you AC, and when you add should give you B. So first of all, we start by getting our values of AC. So for example here, so we have our A being 1, our B equals to 5, and our C equals to 6. So AC is the same as 1 times 6, which is equals to 6, and our B in this case is equal to 5. So in essence, we are finding values, two values, which when you multiply gives you 6, and which when you add gives you 5. Now the trick here is always to use the number which has been gotten by the product. So we always use this number by getting the factors that gives you this particular number. So for you to get 6, you can have a combination of numbers. You can have 1 times 6, that is the first one. You can also have 2 times 3. So therefore, now, when you have the factors, it's upon you now to check, because some of the times you can have the numbers being put in terms of negative and positives. But you can check. For example, we take the first two. When you multiply 1 times 6, it will give you 6. But when you add 1 plus 6, it gives you 7. So it does not give us 5. What about 2 and 3? When you have 2, so let me just, so you have that. So if you have 2 times 3, it gives you 6. Then when you add 2 plus 3, it gives you 5. So our two numbers are 2 and 3. Therefore, you come and rewrite this center number here, the number at B, with these two factors. So you put these two factors with the variable x, and it will become x squared, then plus, so your first value is 2, so you write 2x, then plus 3x, then plus 6. Now remember, we have not changed anything in this equation, because 2 plus 3 just gives you the 5. So we are not changing anything, but we are just simplifying this equation in terms of the factors for us to get this number here. So now take the two numbers, take the numbers in pair, so the terms, so the first, second, third, and fourth. So you can take these two as a pair and this as a pair. So what we have in common between this and this? So we have x. Then we remain with x. So you factor out x outside, so you remain with x. Then you have 2 there. Then you come and take the second pair. So what do we have in common between 3 and 6? So we have 3. Then you remain with x plus 2 equals to 0. What do you note here? There's something very interesting you should note. That this number here, or this term, will always be the same as this. This and this will always be the same. That is a rule. So this term here and this term here have to be the same. So since you have a term here and this term being the same, so take the terms that are outside and any of these, because they are just the same, take one of them. So in short, you should have x plus 3. So you have this term and this term. Then you take x plus 2 equals to 0. What do we know about our two factors being multiplied together being equals to 0? We know one thing. If you have x plus 3 and x plus 2 equals to 0, it just means either either of this term is supposed to be 0. So 0 times anything just gives you a 0. So it is either this term was 0 or this term was 0. So therefore, it is either x plus 3 equals to 0 or x plus 2 equals to 0. Therefore, just take, I want to make x is subject to the formula. So we take positive of 3 to the other side and the positive of 2 also to the other side. So therefore, the solution for this, you can get the solution of x being, so this is positive, goes to the other side, becomes negative 3, and you have x equals to negative of 2. So what we're saying is, these are the roots of x. These are the roots of x. And now, what do you mean by the root of x? Now, it is, we were saying, it is a number which when you put in an equation, it satisfies that equation. So we are saying, if you take 3, negative 3, and put it in this equation, your solution should be 0. If you take negative of 2, put it in this equation, then that should be 0. We can verify them, then we shall take a second example. So let us verify this. So let's take our first term. So we have negative of 3, we have negative of 3 squared, plus 5 negative of 3, then plus 6 equals to what? Equals to 0. So the negative of 3 squared is what? 9, plus 5 times negative 3 gives you what? Negative 15. So this one changes to become what? Negative of 15. Then you have plus what? Plus 6. Want to verify if this one is equals to 0. Now 9 plus 6 is 15. 15 minus 15, what do we get? Our solution is 0. So therefore, this value, this root satisfies this equation. Let's check 2, the second one. So we have negative 2 squared plus 5, negative 2, then plus what? Plus 6. So so we have negative 2 squared is what? It's 4. Then we have 5 times negative 2, that gives you negative 10. Then you have plus 6. 4 plus 6 is 10. 10 minus 10 gives you 0. So therefore we are saying the roots that you get satisfies the equation. Then, now something else to note. When you multiply this term and this and this are called factors. So this term and this term are called factors. So these and these are factors, but the values of x are what we call zeros or roots. Now let's take example number 2. Now we have x squared plus 9x plus 20 equals to 0. So the solution. So the solution to this. Now we are saying we're going to get a number whose product gives us AC. So what is our value of A? Our value of A is 1 times C. What is C? 20. Therefore our product should be 20. Then our sum should be what? The value at B. So 9. So we say we're going to take these two numbers. You compare the two numbers. So we can, we say use the product, use the number that has been gotten using the product. So for example, here we have 20. So what values will you multiply for you to get 20? So the first one is always 20 times 1. Then you have 10 times 2. Then you have 4 times what? 4 times 5. You can have those two numbers. Then from these you try to check which one now gives you, fulfills these two conditions. So 20 times 1 is 20, but 20 plus 1 is not 9. 20 times 2 is 20. 10 times 2 is 20, but 10 plus 2 is not 20, is not 9. Then 4 times 5 is 20. But what about 4 plus 5? Therefore it is also 9. So therefore our two values are 4 and 5. Therefore split this term, the middle term, with these two variables here together with the unknown. So therefore we have x squared plus 4x plus 5x plus 20 equals to 0. Now remember, the order doesn't matter. If you choose to start with 5 times 4, it is still okay. It really doesn't change. So therefore, taking taking a pair and factoring out whatever is common. So let's take these first two. What is common between the two? It is x. Therefore, it remains with x plus what? X plus 4. Then plus plus 5. Then what is common between these two? It is 5. Then you remain with x plus 4. What do you notice again? This term and this term are the same, so they always must be the same. Now take one of these terms and the terms that are outside, so x plus 5. So x plus 5, x plus 4 equals to what? 0. And therefore we are saying, if you have two factors multiplying together to give you a value on the right hand side, it means either this one was 0 or this one was 0 for you to get the solution. So therefore, it's either x plus 5 equals to 0 or x plus 4 equals to 0. So therefore from this you can get the values of x. So therefore x is given by negative 5 or x is given by what? Negative of 4. And those are the two values. Now since this one is a quadratic equation, since the highest power is 2, then it means you need to have two solutions, not one. One is for linear equation, so therefore you have two solutions, and our solutions are x is equals to negative 5 and x is equals to negative what? Negative of 4. Now let's check when our a is not equals to 1. Example, when a is not equals to 1. So remember, when you're writing a quadratic equation, it is ax squared plus bx plus c equals to what? Equals to 0. Therefore, our a now here is not equals to 1. Our b, and we have our c. Therefore, now, in this case, the solution is still one and the same thing. The solution is one and the same thing. So, solution. Again, find the product. And the product is gotten by what? AC. What is our a? Our a is 6. Our c is what? 3. So, what is 6 times 3? Is therefore 18. Therefore, then we come to sum gotten by b. What is our term at b? It is 11. Now again, use the product to find the two terms. So therefore, what do you multiply for you to get 18? We have 1 times 18. We have 2 times 9. We have 6 times what? We have 6 times 3. Now let's combine the two terms and see which one gives us, satisfies these two conditions. 1 times 18 is 18. But 1 plus 18 is not 18. Even if you put, you had one of them to be negative, to still not satisfy the condition. Then we have 2 times 9 is 18. Then 2 plus 9 gives you 11. So I think we already have our solution here. Let's check the last one to verify. 6 times 3 is therefore, 6 times 3 is 18. But 6 times 3 is equals to 9. So therefore that one does not satisfy. So therefore this one satisfies. Now split again the middle term with this arrangement. So we have x squared plus 2x plus 9x then plus 3 equals to what? Equals to 0. Therefore take two terms at a go. So take this 2 and this 2. So what is common between these? We have 2, which is common here and here. Then we also have an x. So therefore we have 2x. Then 2, therefore we'll have 3 there. We have an x. Then plus what? Plus 1. Then plus, what is common between this and this? 3 is common. We factor out 3. Therefore we remain with what? 3x plus what? Plus 1. And what do you notice again? This term and this term are the same. Now taking this, the terms that are outside, the factors that are outside, to put them together, then we have this and this, you pick one of them. Therefore we shall have 2x plus 3, then you have 3x plus 1 equals to what? Equals to 0. And what do we know? Either of this term is supposed to be 0 for you to get the solution of the right hand side being 0. So it is either 2x plus 3 equals to 0. We can solve this first, so we take 3 on the other side. We have x. We have 2x equals to negative 3, then divide by 2, divide by 2. Our x, the first x we have as negative 3 over 2. Then, taking the second term, also or, we say or, 3x plus 1 equals to 0. Then take 1 to the other side, x, 3x equals to negative of what? Negative of 1. Divide by 3, divide by 3. So therefore your x is equals to negative So the procedure of handling the question is just one and the same way. But now you just get the two numbers, which gives you the product and also gives you a sum, and factor out your solutions for you to have the two values of x. Therefore, the two values of x, so x must have two values. So the first value is negative 3 over 2, or x equals to negative over third. Example number 2, 3x squared minus 14x plus 8. So the solution is still the same. So therefore, solution, find the product. So what is our product here? Yes, so what is our product? AC. Our A is 3, then we have 8. So what is 8 times 3? 20? 24. What about our sum? Our sum gives us this term. Now remember, a number carries a sign before it. So this one is not 14, it is negative of 14. So negative of 14. Therefore, using the product, find two numbers, which when you multiply gives you 24. When you add, it gives you negative of 14. Now, let's take the multiples of 24. So we have the first one is 24 times 1. We have 12 times 2. We have 8 times 3. We also have what? 6 times. We also have 6 times 4. Now we take these terms and see which one will satisfy these two. So let's take the first one. We have 24 times 1. 24 times 1 is 24, but when you take 24 plus 1, then it doesn't add up. Now 12 times 2 gives you 24. Then 12 plus 2 it gives you 14. But now we need a solution which is negative. Now let's take when we negate one of them or the two of them. So in our case here, for our case, what if we took negative of 12 and negative of 2? So negative of 12, negative of 2 gives us 24 when you multiply. And what about negative of 12 plus negative of 2? That gives us negative of what? Negative of 14. Therefore, our solution will be this. You can try to take the others, but you'll see one or the other, they do not satisfy a solution that we have there. So, therefore, splitting this number here, we have the equation, we have that square, then minus 12x minus 2x. So remember here we took minus 12 and minus 2. So negative and a negative. Then we have plus what? Plus 8 equals to 0. And remember again we said, you are not changing anything. You have not changed anything in these two, this term here. Because negative 12, negative 2 is just negative 14. What you have just done is just simplified it in terms of the two factors that can give you this in terms of addition. Therefore, taking a pair go, so taking this pair and this pair, what is common here? We have 3 which is here, which is common here and also here. We also have an x and an x. Therefore, we have 3x being common. Then, so remain what inside? X. Then minus, we have 4, there's an x outside, so it is x minus 4. Now, the drill now comes here. What is common between these two? It is, we have 2 and we have 2, we don't have an x here, so we have 2 being same. Then remaining x. Now, for us to get a positive here, when you open up this bracket, what do you need to have here? It will be what? A negative. A negative. Then 2 to that, then we have negative 4 equals to 0. So remember, again, what can guide you here is that this term here should be the same as this term. So if this is x minus 4, then definitely the term that we're going to have here should be x minus 4. Now taking the terms outside and one of these terms, so therefore we have 3x minus 2. We'll take that as a factor. Then we take one of these because it is they're the same. X minus 4 equals to what? Equals to 0. And what do we know? Is that this one equals to 0 or this one equals to what? 0. So the first one is either x minus 2, 3x minus 2 is equals to 0. Now we can solve this one. So 3x equals to 2, then divide by 2, by 3, sorry. Then we have x equals to 2 over 3. Or, remember we're supposed to get two values. So it's either this one or x minus 4 equals to 0. Therefore, we have the value of x to be positive 4. So therefore, for us to get an equation, for us to get the terms, or to get the roots which satisfy this equation, the two roots are 2 over 3 and we have 4. You can try replacing these values of x in this equation and you will see that whatever you get here will always be